ancient Mars was even more Earth-like than we imagined, and it's also something that NASA recently found by the geological experimentation, the research coming from North area oceans, that it had a tremendous amount of ocean water. It's also what the Emerald Tablets written by Thoth the Atlantean revealed to us, that Mars was basically the same type of temperate climate that Earth has. Now, new findings from NASA's Curiosity rover provide evidence that significant amount of oxygen once permeated the atmosphere of ancient Mars. The red planet, it would seem, was more Earth-like than we thought. Using the ChemCam instrument atop Curiosity, scientists at the Los Alamos National Laboratory discovered high levels of manganese dioxide in Martian rocks. The rover made the discovery in mineral-filled cracks in sandstones in the Kimberley region of Gale Crater. The presence of this chemical element suggests that high levels of free-floating oxygen once existed on Mars, and that in addition to having a warmer climate and lakes of liquid water, this planet was once quite Earth-like in terms of its chemical composition. But where did all this oxygen come from, and where did it all go to? Because it's not there anymore. Lanza's team hypothesizes that oxygen seeped out of the planet's water and into the Martian atmosphere as Mars' magnetic field collapsed. Without a magnetic field to protect the surface from ionizing radiation, the molecules within the water split into hydrogen and oxygen. Due to the relatively low gravity on Mars, the planet could not hold on to the lighter hydrogen atoms, but the heavier oxygen atoms stayed put. Over time, this oxygen bled into the rocks, creating the rusty red dust that now covers the surface. Tellingly, it does not take much oxygen to create the red iron oxides, but it does take a lot of oxygen to form manganese dioxides. This means that Mars, for a time, was quite oxygen-rich, and that's an exciting result. Mars may have been habitable a billion years ago or so, so it may have spawned basic microbial life. We have yet to find any proof of this, but we're still looking. Oxygen, which is necessary to sustain most terrestrial life, is used in cellular respiration and other biological processes. Many important classes of organic molecules in living organisms contain oxygen, including proteins, nucleic acids, carbohydrates, and fats. It's possible that exotic alien life might emerge without the benefit of oxygen, but here on Earth, it's been critical. Revealingly, Curiosity is not the only probe to have found manganese on Mars. The Opportunity rover recently discovered high manganese deposits at a site thousands of miles away from Curiosity, so this latest discovery is not specific to Gale Crater. Moving forward, the researchers would like to compare manganese produced by microbes to see how it differs from those produced by oxygen. Until more is known, nothing can be ruled out. And this is on Bended Reality. Please leave your comments, and thank you for your support.